Okay, let's go to the last thing that we're going to be talking about today, and that's percent composition. Now, percent composition, also called percent by mass, is the percentage by mass of each element in a compound. And this gets used a lot in industry. And it's based off of the mass ratio that we just did. When you do percent composition, guys, the percent by mass of each element in the compound must add up to 100%. Now, if you do these and it doesn't look, and you might be able to put, we usually go to the hundredth, so change a 0.07 to a 0.06 or whatever. We wouldn't change whole numbers, but we could change those little bits. This is just a picture I pulled off the internet of the percent composition by volume of substances that make up our atmosphere. We can see our atmosphere is about 78% nitrogen, and nitrogen is very important for plants. There are certain plants that take in nitrogen and make these nitrogen nodules and stuff, and beans come to mind. And then oxygen, of course, is a very reactive gas, and it's 21% oxygen. And oxygen is actually needed for respiration. And of course, carbon dioxide here, that is something that's needed in photosynthesis. So this is the percent by volume in a pie chart of the substances that make up our atmosphere. If we were, well, no, I'm not going to say that. Now, we've been saying, this stuff is important, this stuff is important. Let's see why it might be. Let's say that you are the head of an industrial company and you're mining iron. And I'm going to talk about iron 3 oxide. Iron 3 oxide is actually called hematite in the quote-unquote real world. It's a mineral. And let's say that you mined 300 grams, which is a very minuscule amount, mined 300 grams of hematite, Fe2O3. When I do the percent composition, which I will show you shortly, I find out that in iron 3 oxide, the percent composition of iron is 70%. That means that in any sample of iron 3 oxide, 70% of that sample by mass is going to be iron. And the other 30% will be oxygen. So this tells me, and let's go ahead and do that calculation. So if I mine 300 grams, only 210 grams of that is going to be actual iron. Now, this tells me that if I need 40 kilograms of iron, I can use this to calculate how much iron 3 oxide that I actually have to mine. So, this stuff is used all the time in the quote-unquote real world. Cool, huh? So let's talk about percent composition. Percent composition, the formula for it is the total AMUs of the element in the compound divided by the total either molecular or formula mass, also in AMUs, times 100%. And guys, we can do this also with grams if we're working with molar masses. But for this podcast, I'm going to stick with the AMUs. That's all it is. It's very simple. But you know how I am with rules, so here's the set of rules you need for this. And you need to memorize these, by the way. To find the percent composition of a compound, you, 1, find the masses of each element, just like you did in the mass ratios. You find the molecular or formula mass of the compound, up here. And let's do it. The composition of water, we have, find the masses of the elements. 2 hydrogen times 1.01, you have 2.02 AMUs. You have 1 oxygen, 1 times 16, you have 16 AMUs. And the molecular mass of water is 18.02 AMUs. Okay, well, that's step 1 and step 2. But that we're not at a percentage yet, so let's go on. Step 3, the rule, set up a ratio to determine how much each contributes to the whole. Now, the way I'm going to do that, percent hydrogen, I am going to take the mass in AMUs of the hydrogen and divide it by the whole, times 100. That tells me that by mass, 11.21% of the molecule is hydrogen. I'm going to do the same thing for oxygen. I'm going to take the 16 AMUs that we just saw on the last slide and divide that by the whole. Remember, percent is always part over the whole, part divided by the whole, times 100, and that's 88.79%. So you check to make sure that all of the parts add up to the whole, and in this case they do. They add up to 100%. So this tells us, again, by mass, that in a water molecule, if you were trying to get oxygen from the atmosphere, let's say, if you had a sample of water, you would get 88.79% of it would be oxygen. Does that make sense? If you have any problems with these guys, make sure you come in for help. I'll be glad to help you with this, and we'll talk about it in class too. All right, let's determine the percent composition for the elements in sucrose. And here's the formula for sucrose. So the first step is pretty much done for you. Write formula. Find masses of each element in the compound and find more molecular mass. Divide all masses by the total. Check that it adds up to 100%. Let's do it. You have the formula. Number 2, you find the masses of each element. There's 12 carbon, 22 hydrogen, and 11 oxygen. So we figured that out just like we do molar mass or any mass ratio or any other stuff. And then it says, and find the molecular mass. To do that, of course, we just add up these masses. So we have 342.34. In this case, we would be using AMUs. Number 3 says that you divide all the masses by the total. And that's what I have here. The carbon, on the last slide, it was 144.12 AMUs. And the molecular mass, the mass of a molecule of sugar, is 342.34. When we multiply that by 100, we get 42.1%. For the hydrogen, as we saw on the last slide, 22.22 AMUs for the hydrogen, and 342.34 is the molecular mass. We divide times 100, we get 6.49%. And for the oxygen, we have 176 divided by 342.34 times 100, 51.41. Excuse me. So, I mean, that's all you do. And you've been doing this for a while now, and this is just multiplying by 100, so you get a percentage. Easy stuff. Don't forget, it all has to add up to 100%. Okay? Now, notice too, as I do these, I always keep them with the elements in the order of what the elements are in the formula. The carbon, the hydrogen, and then the oxygen. Now, I decided for some reason that I can't fathom to take the time to put this into a pie chart for you. I had used the pie chart earlier when we first started talking about percent composition. And I thought, oh, I think I'll put this in a pie chart for them. And so all this shows is here's the oxygen. It has the larger percentage, but it's not all that much larger than the carbon. But the hydrogen is just a little bit. And that would be expected because hydrogen is very light, very, very light. Even though there's more hydrogen than either carbon or oxygen, because it's very light, and this is percent by mass, it's going to be the smallest amount. Now let's go ahead and do that percent composition of the iron 3 oxide that we talked about in the beginning. You want to try to do this, guys? I'll put the steps up. Don't forget, you have to learn these. First thing you're going to do is write the formula, and that's nice that the formula has been given. You find the masses of the elements in the compound and then find the molecular, or actually that should be formula mass, I apologize. 3, you divide all masses by the total. And 4, you check that it adds up to 100%. Go ahead and do this, pause, do this, and then come back and we'll work it through. Okay, here's the formula. Iron, there's 2 iron times 56 equals 112. Oxygen, 3 times 16, 48. You add these 2 up, you get 160. So it'd be 160 AMUs for 1 formula unit of iron 3 oxide. Then you take the 112 from the iron, you divide it by the whole, the part by the whole. We want to know by mass what percentage of this formula unit is iron. And we find that it's 70%, or yes, I'm sorry, 70%. And that the oxygen, 48 divided by 160 times 100 is 30%. Remember, guys, it always has to add up to 100%. And you always do it in the order of the elements in the compound. Okay? Do the following problems, show your work, and be ready to put them on the board in class. Find the percent composition of the following. And we're not done here. I have a couple more slides. Okay? Go ahead and write these down. And then I'll finish up here. When you're done writing them down, come back.